following. And in 1 or 2 sentences, explain why. So, the time between lightning flashes in a storm. The type of students writing this exam, human intelligence, measured as IQ, and severity of asteroid impacts. Very slightly unfair question. We definitely spent lots. We spent a bunch of time talking about how Gaussians show up in nature, and we spent loads of time talking about how 1RF and power laws show up in nature. We spent a relatively modest amount of time talking about the other distribution, which can show up. And so I would, in another year where I rebalance that particular discussion, this question might be more fair. This distribution is exponential. And that's the one that I didn't talk about very much this term. So I did derive or argue persuasively why, given independent events, the time between them must be exponential. But honestly, we didn't spend a lot of time talking about it. But here, the argument would be something like, yes, it's exponential. Why? Because the inter-arrival time between independent events must be exponential, and large storm, lightning strikes are likely to have only very limited correlation. So somehow you'd at least have to state the argument. It doesn't have to be right. I mean, probably lightning flashes aren't independent because once you've discharged electricity, it's not suddenly available. But in a large storm, the fraction of discharge is so small that they're pretty close to independent. Height of students write this exam. So height is a clearly bounded kind of limited physiological attribute. You can't be too short, you can't be too tall, so very likely it's Gaussian. Human intelligence, same argument applies. Anytime I have a phenomenon which is pretty strictly bounded in range, then very likely it's Gaussian, close to Gaussian. You could probably argue why it's not quite Gaussian. Well, for one thing, the tails aren't infinite. You can't go below 0, stuff like that. But it's probably pretty good. And then this one, it's hard to come up with a power law behavior that's not stunningly obvious once you've taken this course. So it's kind of a giveaway. But still, I'm making you write a sentence or two down to explain why. And I want to see how persuasive you can be. All right? But I can't, in this case, I don't know that I could create argument for self-organized criticality. We'd have to know an awful lot about astronomy and asteroid formation to try to come up with any argument there. However, the historical record shows that small asteroids are very common, medium asteroids are somewhat less common, bigger ones even less common, even bigger ones even less common, and so forth. So you would say something like the frequency of impacts is inversely related to the size of the asteroid, and so therefore this looks very much like a heavy tail or most likely a power law distribution. We wouldn't know whether it's power law until we actually looked at the statistics, but it would not be wrong for you to say power law here because I haven't given you any statistics. Okay? It's only wrong if I actually show you distribution. Then you shouldn't just jump to power law. Then we'd actually have to say, look at it log log. All right, make sense? Okay, I want to leave myself 10 minutes. I got 2 minutes here. I'm going to read the next couple, just jot down in point form. So next question, define a catabolic system and give 3 examples. Okay, so for catabolic, you would not have to say anything about closed, open, or isolated necessarily. So a catabolic system is basically one that consumes itself or uses up some parameter or some aspect of its internal resources. Okay? Whether that's energy or reserves or minerals or some other abstract concept. 3 examples. Well, these should be so easy by the end of this course. Okay, so like a person not eating would be an example of a catabolic system. Almost any kind of modern society as related to sort of energy, like gas exploration and consumption, oil, tar sands, agricultural minerals, basically any kind of extractive thing that we do where we end up dumping the problem somewhere else, right? Take it out of the ground, use it, dump it in the ocean. Take it out of the ground, use it, dump it in the landfill. All of those are catabolic, except viewed planet-wide. Okay? Because obviously the potassium isn't leaving the planet, it's just leaving one system. Next, consider Canada as a system. Is it catabolic? Question mark. Why or why not? Okay, that's a tricky, open-ended kind of question. Consider Canada. Okay, so we've got the whole country. So draw a system envelope. So this is getting back to the first assignment with the system envelope. So you're drawing a system envelope around Canada, and the question is that system inside of that envelope catabolic? Well, probably you could argue both ways. Here, keep in mind, I would probably clarify what I'm looking for. I would probably say no more than 2 paragraphs, because you could write an essay, you could write a thesis, right? So I would probably want no more than half a page, because I really want to see the essence of your thoughts. I don't want a long, persuasive discussion. I want you to get right into the point. And so what would the point be here? Well, you could even say, it depends by which parameter we want to measure. But as a resource-intensive, extractive economy, Canada is a net exporter of energy: gold, silver, oil, gas, lumber, agricultural products. So by almost all of those metrics, Canada's a catabolic system. If you want to be a little controversial, you could say, from a human metric, since we have more immigration than emigration, Canada is an anti-catabolic system in that we absorb people. So I don't mind a creative input like that, but make sure you're getting to the essence. That is, don't just ramble on about something. The definition of catabolic, you better be answering consistent with how the question's stated. Okay. Last question I had written down here. Looking at agricultural nutrients from a systems level perspective, give an example of nutrient systems which are more or less option 1, open, option 2, closed, option 3, isolated. So in other words, we talked about nutrients, so give me an example of systems for each of those 3. And I said more or less, because it's hard to have one that's exactly any one of those. Again, I would have to clarify how much detail I'm looking for and whether I need any justification. But an open system would be almost any kind of modern agriculture with runoff. A closed system would be probably close to any really traditional, either hunter-gatherer or any kind of traditional sort of fallow-based agriculture. Isolated, then that's a tricky one. Not clear whether there are good examples. You could say it's highly speculative whether such examples exist. There are probably islands, in the Pacific that are essentially completely isolated, except not isolated in terms of energy. Isolated systems. I don't mind an answer there saying that, you've made like ocean vents, but they have energy coming from the Earth's interior. Maybe the planet as a whole, but it's getting energy from the sun.
Solar system.
So yeah, solar system. If I thought about that question for a while, I might remove isolated. Okay, so that gives you a little taste. The thing that's missing here, the kind of question that's missing, I didn't ask anything here specifically about power laws. That's one thing that's missing. I did not ask anything about self-organized criticality. That's a big omission from this list of questions. Because we definitely talked about that. You did, you did your cellular automaton kind of examples in the assignment. So that's a pretty key sort of topic that's not showing up here. I have nothing here on sensing or inverse problems. On sensing, what might I ask? At a sort of a light flippant level, I could ask, why is the sky blue? And you could mention something about scattering, or a scattering of sunlight in the atmosphere.
An example of different types of scanning